Welcome to this video where I want to build a basic progressive web app with you. Now, I already do have a video about progressive web apps on my channel. You can find a link in the video description, of course. And this other video is basically taken from my complete progressive web app course I host on Udemy. Of course, you can also find a link to this in the video description. Now, in this video here, I want to build a progressive web app with you, which works offline and which we can install on the device home screen of an Android device. So let's do that. Let's dive into that and let's learn what it takes to create a basic progressive web app. So in the video description, you can find a link to a starting project which I already opened in WebStorm. It's a very basic project, and as you can see in the README of that file, you'll need Node.js to run this development server this project uses, and you'll also need to install the dependencies, though that dependency is really just this one dependency here, a HTTP server, and then we have the start command which spins up the HTTP server. So let's do that. Let's first of all run an npm install to install that server, and once we did this, we can start it with npm start, and of course keep that process running because we want to keep our development server running. You'll then find the addresses under which you can visit the project in the console, but you can also simply visit localhost 8081. Now this page is a very simple web application. It's not a progressive web app at all, and all we can do right now is we have this huge card here which you can click, and when we click it, then the text down there changes with a little animation, and we can go back and forth between the different content. So obviously the application here might not blow your minds, but the cool thing is that this is a nice application where we can add progressive features or features of progressive web apps to make it a progressive web app. I strongly recommend checking out that other video I mentioned, which I took from my complete guide, to get you into the basics of progressive web apps so that you learn why you might want to build them and what makes up progressive web apps. Now with that, let's turn this application into a progressive web app by, first of all, adding a manifest file. A manifest file is a file which is read by the browsers, by browsers supporting it at least, and this file then allows the browser to get some extra information about your page. Something like the icon it should use, or for example the name, description of the page. Things like these which allow the browser to display your page correctly and, very important, to install it on the home screen with your own icon and so on. So this is the idea behind the manifest file. In general though, we need to understand which browsers do support which progressive web app features. Let's have a look at that. On the Web App Manifest page of the Mozilla Developer Network, you can not only find some information about how this file should be structured and which properties you can add. I strongly recommend this article, but of course I will also walk you through the most important properties in this video. But you can also find, if you scroll down, you can also find some information about the browser support. Now, what you see here, browser compatibility, that it's not supported at all. That's not entirely true. Many features like installing it on the home screen simply doesn't work on desktop like that. But if you check out mobile, that's the more interesting part, because that is where we want to add our application to the device screen. And there you see how it is supported, and support is pretty well on Android. Now iOS and Safari, the support is not there yet, but Safari is also working on progressive web apps. We see some development there, so chances are that this file will also be readable by Safari on iOS or other browsers on iOS in the future. So for now, let's focus on Chrome for Android and all the other Android browsers, and there we see it's pretty good. So this is the Web App Manifest, and to use such a file, we should add it to our project. Now, the application is actually served from the public folder. This is where all the source code of the web app you saw lives. Now, if we have a look at it, there we have index and HTML file, and then we have our source folder with the different assets, scripts, images, and so on. Now, important, here I only got one HTML file. I'm not creating a single page application here though. Well, it is only a single page, so I guess technically it is one. But I'm at least not using any framework. I'm not using Angular, React, or Vue here. If you check out my JavaScript file, it's a very simple file using vanilla JavaScript. And this is important. You can turn a single page application driven by React, Angular, and so on into a progressive web app. You can also turn any other application into a progressive web app. Also multi-page applications. And the course I mentioned at the beginning, my Udemy course, actually uses a multi-page application to show you how versatile this concept is and that you can apply it to any web app. That's really important to me that you understand this. Any web app. So back to the manifest.json file then. The right place to add it is right next to our index.html file. So there I'll create a new file and I'll name it manifest.json. It has to be a JSON file. Now with that added, without any content in it yet, I'll go to the index.html file and there at the end of the head section, I'll now add a new link. It won't be of type style sheet though. Instead it should be relating to a manifest. And the link should simply point to /manifest.json, so to this manifest file. Once you did this, we can start filling this file with life, and since it's a JSON file, we should of course write JSON code in there. So what goes into such a manifest.json file? First of all, you can give your application a name, like a basic, progressive, web app, whatever you want. This name will be used in some places, for example on the splash screen, which Android will automatically show you if you start your application after you installed it on the home screen. However, there are also places, like below the icon, where this name is simply too long. That's why there's also a short name property. And this should, as the name indicate, be a short name, like basic PWA. This will be used below the icon on your home screen, and to make sure it's not getting cut off, you should pick a short, string, a short text here. Now beside that, we also have a start URL, because, all lowercase by the way, because if you think about your app being added to the home screen, and the important part about this installation thing, which I'll later show you, is of course that all the time when I say install, it's still a web app. It's not a native Android app you're running then. It is a web app in its core. It's going to visit your web page, which gets served from your servers. So this is why we have to specify a start URL here. And you could just say dot to simply use this folder where the manifest.json file lies in as a start URL, which makes sense for me here because that's the public folder and that is our root web folder. But you could of course also say /index.html or whatever it is. So I'll go back to dot though because I simply want to serve my root folder whenever the user taps this icon on the home screen. Now there's also another important property, that's the display property. Here we can control how our progressive web app runs in the end. If we open it from the home screen, I mean, does it look like it's running in a browser with the browser toolbar at the top? Or does it look like a real native app? Still, again, it will always be a web app, but we can change the way it looks. And to really create an immersive feeling, we might want to pick standalone here. Other alternatives would be full screen or browser. So here I'll pick standalone to really make it look like a standalone application and therefore reassembling this native app look. We also have orientation. Now orientation allows us to control how the user should view our application. Now we can't rely on the browser enforcing this actually, or the device, but here we could say portrait to make sure that this app can only be viewed in portrait mode if started from the home screen. So I'll add this here too. Another nice thing is the background color, and this is again all lowercase here. The background color is for example used on the splash screen, which is created automatically, which will be the background color and your app icon. Now I'll come back to that icon thing, but that is for example where we set the background color. What the background color here is not is the background color of your general page. So it's not this white background here. This is not controlled through the manifest. I'm really talking about the background during startup of the application, for example. So here, why don't we pick some grayish color? We also have a theme color. And the theme color now, for example, styles the toolbar. Already, when your application runs in the browser toolbar color should change. But also, especially, if we started our app through tapping the icon, and then, for example, we open the task switcher on our mobile device, we will see that our application runs as a separate task colored in our theme color. So that is where we can see that. Now, you can pick any color. I'll simply pick a color from this image here. So maybe this blue here, which is the following hex code, 5FAAE5. And that, again, will be used in some places, for example, the task switcher. Now, with that, we can go to another important part, the icons. And this is icons, not icon. And icons is an array because you can specify multiple icons in different sizes, basically. Each icon is defined as a JavaScript object here in this JSON file, and then has three properties. The source pointing to the icon file. Now in this project you are using, you already will find this images folder, and in there this icons folder where I prepared some icons for you. And here we can simply point to them. So we can say source images icons, and then for example app icon dash 96 by 96.png. That is the path to the icon I want to use. We also have to explicitly set the sizes of that icon, because we can probably guess that it's 96 by 96, but of course we could have named this file anything we want. So we clearly have to tell the browser what the size of that icon is. And here it's 96 by 96, and this is how we should specify this format, this value here. Now, why do we need to tell the browser the size of the icon? Because the browser should pick the right icon for the different devices where this application might run on. And depending on the density of the screen and the resolution of the screen of the device, it should pick a well-fitting icon. The last property for each icon is the type. And here, this is image PNG, and it should be a PNG image if you want to use it as a home screen icon, as a splash screen icon. Theoretically, other formats are supported here too, but to have an installable application where Chrome actively prompts the user whether he wants to install it, add it to the home screen or not, you should set this. At least this is the case right now. Now this is one icon, but we got more icons stored, so I'll specify them all. The next one will have the dimensions 144 by 144, and this is actually an icon which you should always provide, this dimension 144 by 144. This is an icon which is required so that Chrome shows this, do you want to install this app, pop up to the user basically. 144 by 144 has to be provided. If you don't provide any other icons, provide this size. So the next icon I want to add here is of course the next icon I have in that folder, so 256 by 256. And then let's add the last icon. This last icon here is pretty important for the splash screen display, though it will work without it. Now, this is a basic app manifest, a basic manifest.json file. Now with that, let's save all of that. And let's go back to this application. Let's reload it and let's open the developer tools. Now I'm using Chrome here, and I strongly recommend using Chrome because they have awesome developer tools when it comes to debugging or working with progressive web apps. There you can visit the application tab, and let me increase this. So there you can visit the application tab, and there you will find this manifest area. If you click on it, you should see the information the browser could get from the manifest you specified. So the name, the short name, the color, and all the icons you specified here. So that's awesome. This seems all to work fine. Now we could already manually add it to the home screen. We could go to a mobile device, an Android device, simply open this application if it were to run on a server, and then tap the Add to Home Screen icon manually, the Add to Home Screen menu option. We should then already use this icon and so on, but Chrome won't actively prompt us to do that, to install it. However, there are some criteria, and a link to the criteria can be found in the video description, which define when Chrome will show you this actively. So when it actively asks the user whether he wants to add the page the user is currently on to the home screen or not. Now, right now, when I record this video, the criteria are that you have a manifest.json file with a 144 by 144 PNG icon, that you, of course, should specify name and so on, short name, and that you also have a service worker. We don't have that yet. That you also visited the page with a 5-minute pause in between, but that you came back basically because you probably liked the page. And that is important, that your page is served over HTTPS. Now, during development, localhost is actually an exception, but you should serve it over HTTPS because service workers require HTTPS, and service workers are a requirement for the app manifest. Again, localhost is the single exception that exists, where you can also serve your progressive web app over localhost and see all the features. But of course, that's not available when serving it on a real server. So there, make sure you're serving your page over HTTPS. So with that, we got the manifest. Let's now add a service worker. And for that, I'll add a JavaScript file because a service worker is just using JavaScript. You could be inclined to add it in the JavaScript folder in the source folder, but here's the important thing. A service worker always has a scope. Scope defines which pages a service worker can control. Because a service worker is JavaScript, but not like your normal JavaScript, like here in the app.js file. A service worker isn't attached to a single page, a single file. This app.js file is. It gets loaded by the index.html file here at the bottom, and it is attached to this file. This is the reason why in app.js we can access the DOM of this index.html file. Now, a service worker is also registered through your pages, but I'm deliberately saying pages because you could add it on any page. But then it runs in the background on a separate thread. So not on your main UI thread like this script file runs, but on a separate thread. This also means that, for example, on Android, it will keep on running even if your page is closed, which is amazing for getting push messages, for example, something I do show in my Udemy course. So this is a service worker. It runs on a separate thread. It's not connected to a single page, but instead it has a scope which could be your entire domain, all the pages on the domain, or a subset if you limit the scope to a given folder in your domain on your web page here, so to say. And that's the important thing. If I were to add my service worker in this JavaScript file, the service worker could only interact with pages stored in the JavaScript file or in subpages. That, of course, isn't helpful because we haven't any pages in there. So we should create the service worker on the public folder here. So I'll create a new file, and you can name this file whatever you want. I'll name it sw.js. This is a file which will hold my service worker related JavaScript code. And again, it's not attached to a single page. It is event driven, and it can listen to events fired by any of your pages or other events not even coming from your pages, like incoming push notifications. Now here, I want to react to some events triggered by my index.html file though. And first of all, we should register this service worker. This is done in JavaScript and of course in your normal JavaScript, because you have to tell the browser, hey, here's a service worker related to my page or a subset of my pages. Please register it. And if the browser doesn't know this service worker yet, or the service worker file changed, so if the file size changed, the browser will take this service worker and register it, overwrite the old one, or register it as a new one. The code to register a service worker, therefore, as I said, has to be added in the app.js file or directly in a script part in the index.html file. And in there, I'll now simply add navigator, that refers to the browser, service worker dot register. Now, here's an important thing. You should make sure that this code where you register a service worker gets executed on every page in your application, so that the user, if he visits a different page and not your main page, if you had multiple ones, so that even if the user visited some other page like /about, that he still installs the service worker. And then again, you have one service worker for all the pages. So it's always the same one you register, but the user might enter a different place, a different path in your app. So you should be prepared for this. Back to the registration code. There you pass an argument to register, and that simply is the path to the service worker file. So in this case, it's /swjs, pointing to the root folder and then swjs. This is the service worker I want to register. Now we have one issue here though. This code will work fine on Chrome on the latest version. However, what if the user uses a browser which doesn't support service workers? We can check service worker support on is service worker ready. This is a page on jakearchibald.github.io. Link can be found in the video description. And on this page, you see the different service worker features and which browsers support it or are working on it. And you see that Chrome and Firefox support is decent, but that Safari and Edge are working on service worker features, the general features or some special features. So if the user uses Safari or Edge right now, the code we wrote here, this one, will throw an error because the browser can't handle this. There is no service worker object on the browser. So what we should do is we should wrap this into an if check, where we say if service worker in Navigator, so if this object exists in the Navigator, then we want to execute this code. Otherwise, we won't register a service worker. That of course means we don't have access to the features we are about to add, but that doesn't matter because the browser doesn't support it anyways. So with that, we registered the service worker. Now we can fill the service worker with some life. Let's go to the service worker. And I said that the service worker is event driven. You always react to events in there. So what you can do is you can add an event listener. You add it on self. This refers to the service worker process, so to say. And then you call add event listener. And now there is no click event or something like that because we're not reacting to DOM events here because the service worker is decoupled from the DOM. You can't access the DOM in a service worker. But there are other events available. For example, the install event. This will be fired when a service worker is, you guessed it, installed, which is the case, as I mentioned, if it's brand new or if it's an updated version and the browser replaces the existing one for the given scope, for the given domain in this case. So if the install event fires, then I want to execute a function here. And in this function, I'll first of all simply log service worker installed. This is something I can do here. Now we'll soon add more code to the install event though. Let's also listen to the activate event here. Now in the activate event, we know that it has been activated. And the difference between installing and activating is that installation happens instantly if the browser detects a new service worker, but it will keep it waiting until it activates until you or the user using your page closed all tabs in his browser where your page was open. The reason for this is simple. If you install a new service worker and you overwrite the old one, if you would immediately activate and replace the old one, then you might break the page the user is currently visiting because maybe your page is firing some event to which the service worker should react, and you suddenly push a new version onto this page. Now, existing processes might get interrupted, the page might not work anymore. That is why we have two separate steps here. And it will only activate after the user closed all tabs and then opened it again. Then the installed service worker will get activated. So these are two events we can see here. Now, let me also go back to the app.js file and chain something to the registration. The register method returns a promise, and therefore here I can execute a function where I can simply log service worker registered. Now with all that added, let's see this in action. So the server is still running. I'll go back to my application here and I'll reload it. Now if you go to service workers here, you should see that a service worker was registered. And this is the scope of your service worker, this domain. Here's the service worker file. You see it's activated and it is running. And this is your first service worker added. Now, the service worker like this doesn't do too much though. You typically, the most basic usage you can do, you typically use it for caching. Caching means that you can actively add some files to your cache, a special cache, not the default browser cache. And you can also define when these assets should be served, so that you make sure that your page even works if you're offline. Let's add such a functionality in the service worker. And the best place to cache some files, which you know will not change that often, you always want to be able to access them, is in the install step here. Because there you can pre-cache the static assets of your page. You do this by simply reaching out to the cache API, a special web API which allows you to access this special cache I was talking about, not the default browser cache, but a cache you can manage. You can use caches open to open a cache there. Next, you pass a name. And this could be static or whatever you like. If it doesn't exist yet, like it does for the first time you execute this, it will simply create it, and thereafter it will open this cache. Cache is open returns a promise. And in the function which gets executed once the promise resolves, we get access to the opened cache. So let's pass this as an argument. Now in this open cache, we can call the add method to now add an asset for caching. Now the add method is pretty cool. We can simply add a path to an asset here, and the browser will automatically make an HTTP request to that browser and store the incoming response in the cache. It will actually store a key value pair in the cache, where the key is your request and the response as well, and the value is the response you got back. So here we can simply specify a path. Like for example, let's say we want to cache the app.js file. So we could cache source.js app.js. We also might want to just cache / so that if we visit just localhost 8081, nothing else, we have this response cached. We should also cache /index.html because that's not the same as just /. Both load the same file in the end, but these are different requests to different endpoints. Now with that, we would already cache quite some files. We wouldn't cache any images and CSS and so on though. And you can see that you're calling cache add a lot. Now that's fine, but I'll comment it out. There is another function which is cache add all. Cache add all takes an array of strings and simply does all these individual additions automatically in one turn. So here again, you can now cache /index.html. So this is just an array of strings, as I said. Source.js app.js. And what else we have? Like for example, source CSS. And in there, we have the app CSS file. Now we also might want to store an image. So here we could now store source images PWA.jpg. You could also store the icons here. Now I will store something else though. If we have a look at the index.html file, there you will see that we're also reaching out to a CDN to fetch this font. So what I'll do is I'll also try to cache this. So I'll copy this URL. You can cache assets from other servers too. It's not just from your server. You can enter any URL into the cache add method. So I'll reach out to this CDN here by simply adding this URL here too. And keep in mind, these are all just URLs. These are relative URLs on your own server. And this is a URL reaching out to another server. In the end, the browser will make these requests and store the response for you. This code won't work though. Service workers are only idle working for an unknown period of time, and then they will shut down. To make sure that the service worker doesn't shut down before caching is done, we can take advantage of the event which we get passed into this function for the installation event automatically. This event has a wait until method. And we should execute this to make sure that the service worker waits for a certain process to finish before it possibly shuts down. And shutting down doesn't mean instead, it's just paused, so to say. And it will wake up the next time it receives an event. Now we can take caches open, which returns a promise, and pass it to wait until. Wait until conveniently expects to get a promise. So this is just fine. Now with that, it will wait for this process here to finish before it possibly goes into idle mode again. Now let's try this out. Let's save this. Keep in mind, we now changed the service worker file, so the file size changed, so the browser should install the new one the next time we refresh the page. So let's do that. Let's refresh the page. And there you now see, if you go to Application Service Workers, that we got a new service worker waiting to activate. In the console, we therefore see that it was registered, that it was installed, but that it wasn't activated yet. To activate it, we have to close this page and reopen it. Close all active tabs with that page. And the next time you visit your developer tools, you see it's activated and running. You'll also see, also under application, if you go to cache storage and right click it to refresh, you'll see there is a static cache here. This static cache actually cached all the requests you specified in your service worker. You also see the response here. and the date and time when it was cached. Now with that, we haven't gotten offline support yet though. All these things are cached, but we never try to fetch them. So what we can do is we can add a new event listener to this service worker. And this is for the fetch event. Now the fetch event is, for example, triggered whenever you fetch something in the index.html file, like through this link, or through this link pointing to the app.cs file, or through this link pointing to the script file. Whenever this is the case, a fetch event is registered in the service worker. Now for the fetch event, we can now react with a function where we also get an event as an argument. And now there, we can decide what we want to do. If we don't do anything, the default will happen. The browser will go ahead, reach out to the network and make that request. But we can change that behavior. We can basically use our service worker like a network proxy here. We can use event and now not wait until, but respond with, to make sure we respond with something different than the default network request. Now here we could respond with our own fetch request to some other URL, or we simply reach out to their cache and try to find the given network data from that cache, get it from the cache. The data we wanted to get, I mean. We can do this with the caches API again, and there we have a match method. This allows us to match the incoming request with some resource in our cache. So we should simply pass event request. There is a request object on the event object. And now the cache API will have a look if in any of its caches, in this case we only have one, but we could have multiple ones, if in any of the caches it finds this request. And for some assets it should indeed do that. If that's the case, or actually always, it will then execute a function where we get the response from the cache, not from the network, back. Now this will also be executed if it doesn't find something in the cache. So it will not fail, it will not throw an error, response will then just be null. If response is set though, we can simply return the response. So we return the response from the cache if we have it in there. Else, we can simply do something, else we can reach out to the network. So we can then make the fetch with the fetch API. This is supported by all modern browsers, and since we're in a service worker which only runs on modern browsers, we can safely access this. So fetch is now available, and fetch will now make a network request to event request, for example. And there we can then simply return fetch, which is of course a promise. But we can return a promise or directly the response. Both will work here in caches match. And this code should make sure that if we have the request in the cache, we get the response from the cache. If we don't find it in there, we go ahead and make that network request. Let's see if that works. Let's save this and let's reload the app to install the new service worker. Now as before, it's waiting to activate. So let's simply close that tab and reopen it. And let's have a look. It was activated. Now let's see if this works. If I reload, this all works. But now under service worker, here in application, let's go offline and let's reload the app again. And even though I'm offline, I am offline. This is simulating that I'm offline. The app looks like before and it still works like before. I can still tap this. The reason for this is, and we can confirm this if we have a look at the network tab, that we're getting these assets from the service worker here. You see that from the service worker, we're fetching it from there. That's of course the cool thing, because now we got an offline ready application with a service worker. Now you can fine tune this whole caching and get something from the cache thing way more. There are different strategies you can use to get something from the cache first, but then reach out to the network to get a more up-to-date version of that asset, but to go to the cache first to show something on the screen immediately, and so on. And I will walk through all these strategies in my Udemy course, which I mentioned at the beginning, linked in the video description. This basic caching here, this pre-caching we're doing here, already is a huge first step though. Now with that, let's see how that looks like on a real device. It should actually also work on an Android emulator, for example, one you create through the Android Studio. So feel free to do that if you don't have a real Android device. I'll quickly connect my real device with my computer though, and then I'll try to see this run on the device and see how the application looks there. Now I connected my real Android phone with my Mac here. And the cool thing is on Chrome, if you have Chrome on your Android device, again, should also work on an emulator, and you have Chrome on your Mac or on your Windows machine too as your default browser, you can go to the developer tools on Chrome for desktop, these three dots you see in the top right corner, and then more tools, and then remote devices. Now if you expand this here, this simple window, you actually see all connected Android devices. Now there you should also make sure that you check port forwarding so that you can visit a port a server I should say, running on your local machine, on your desktop machine here, also from your mobile device. Because by default, if you enter localhost 8081 on your real mobile device or the emulator, this will not be your page on your machine here. This will be localhost on the device, which is the device itself. But with port forwarding, you can make sure that you can enter localhost 8081 on your device and visit the server running on your Mac or Windows machine. So with that, let's now simply go to that connected device, my OnePlus here, and there I now will simply open a new tab. So let me quickly do that. So now here in Chrome for my desktop machine, I can inspect this tab I opened. And I now got these same developer tools I have on my Mac, Chrome. Here on my Mac, still this window is running on the Mac, but it's referring to the page running on my mobile device, which I can show by tapping here and so on. And you see, I already get this installation banner here. You can also manually trigger it by going to Manifest and then clicking Add to Home Screen in the developer tools connected to your device. Now I'll click Add here. And now it's again, well, as I just said, adding it to my home screen. If we now have a look at that, here it is. If I tap it, here it opens. And this is now opened through the icon on the home screen. Now, right now, at the point of time I'm recording this is a bit buggy, at least for a localhost testing. There you see, it still looks like it's running in the browser, even though I opened it from this icon. And I promised you that it would look like a standalone app, at least since we set display to standalone in the manifest. Now, on localhost we get this bug. We don't get it if we serve this from HTTPS though. So why don't we quickly do that as an extra bonus task to make sure to really ship this to a real page so that we can see how it would work if we were to serve it from HTTPS. Now you can upload it to any of your favorite hosting providers as long as you ensure that your application or your hosting, your server does ship the app through HTTPS. I will use Firebase because it's super simple to set up and super simple to get started. So I'll quickly head over to Firebase and there I'll go to the console to create a new project for that. And again, you can use any other hosting provider as long as your app is served over HTTPS. So here I will name this basic PWA, and the region can be whichever region you want, Germany, and create this project. Now, Firebase also offers a lot of other features like database, which I won't use at all here. I'm just interested in the hosting. So once this is finished, I want to, well, host my app here. So if I click on hosting and click on get started, you get instructions on how to host your application. And first of all, you should install the Firebase tools. Again, of course, only relevant if you are using Firebase. So I'll quit my local development server and I'll quickly install the Firebase tools globally on my machine with sudo npm install-g Firebase tools. This is basically a CLI by Firebase, which allows us to do some things like easily deploying it to our web server. Now, once this is finished, we can simply click continue here in this window to see the next tasks. We should sign in and then initiate our project. Now I already am signed in, so I'll type Firebase init here to put this project folder under control of Firebase, and I'll simply just check hosting here by hitting the tab bar in this drop down in this menu and then hit enter. And this will now set us up to be a hostable project. Now I have to pick the project, and it's basic PWA for me, the project I just created. I'll confirm that my root web directory should be the public directory, which is the default. I will check no here. It's not a single page application, though that theoretically would be one, and you could write Y for yes here, but I'll write no. And I don't want to override the public index.html file, so I'll enter N here for no too. With that, it's initialized, and the last step is to enter Firebase deploy. So let's run this deploy to ship this project to a server. And once this is done, we'll also get the URL under which we can visit this here too. So let's wait for this to finish real quick. And now that it finished, this is the URL where we can visit our project. Let's quickly check it here on Mac. So I'll quickly enter it here instead of localhost. Looks good, looks very good. Let's reload this one more time. Let's now try offline mode here by going offline. It's looking decent. Now let's try it on the mobile device. So there I'll visit the same URL. Of course, you should enter your URL. And I see my project here. I'm also asked whether I want to add it to the home screen or not, so I'll quickly do that. And whilst it has the same icon, it's a different app for my phone here because it's not running on localhost. And now if I tap this icon, now you see what I meant. It's running standalone like a real app. And if I open the task switcher here, you actually see this here is the app with the theme color. You can see the blue toolbar. And here is Chrome. So it's running as a separate process, even though technically it still runs powered by Chrome. It still uses Chrome. It still is a web app, but it looks like a native app and behaves like one. So that's the cool thing. Here we got this application. And finally, if I check offline mode here too, by simply going into airplane mode real quick, if I now reload the app, you see it's still working. It's still working fine here. And now if I re-enable internet, we're back to the online experience. So that's the cool thing. This is how it looks like if we run it on a real server. Again, any server you like, as long as it's over HTTPS, since that is a service worker requirement. And I hope this video gave you some insights into how to create a basic progressive web app which is installable and which pre-caches some files to give you a basic offline functionality. If you want to dive much deeper, check out my Udemy course. And of course, I'd be more than happy to also welcome you in all the other future videos on this channel. Bye.